So here we have a question that is very similar to question 2 on the homework sheet that you've been given. Let's make sure we know where this type of question is coming from. We're basically looking here at chapter 9, and we're going to be using formula 9.4 to solve this. And let's take a look at how this formula works. Present value equals future value divided by 1 plus I to the power of n. So in this case, what do we know? We know the future value equals 1,800. We know the value of the rate of interest, I, equals 7.2%. And we know that n, the time period, equals 3. So we're basically trying to solve for present value equals 1800 times, divided by 1 plus 7.2% bracket to the power of 3. And let's see what that equals. When I plug this into my calculator, this is what I'm going to have to do. 7.2, hit the percent key, plus 1 equals, I can see what that is, but I don't want to take it out of the calculator. Then I'm going to hit the Y to the X button and go 3 equals, see what that is. Don't want to take it out of the calculator. Now, I've got everything here in the denominator, but I want to flip it into the numerator. So I'm going to hit the 1 over X key, which is going to flip that into the numerator. This is my invert button. Whenever we divide fractions, we invert and multiply. And this 1 over X key is the invert and multiply. On some calculators, this is X to the power of -1, which is the same thing. And I'm going to go times the 1800 equals, and I get some kind of an answer. 146,127,615. But of course, we're working with money, so I've got to go to 2 decimals. 1461.13. Let's keep it all on one line here. So that's all fine and dandy, but as I mentioned in the previous video, we also very much want to know how to do these things on Excel. So let's go over to Excel. So new share my screen, get rid of all this nonsense, go into Excel, and you may recall from the previous video that you hopefully watched is that we created this document, so we don't have to do this every time. So there we have, this was question 1. So we'll keep track of that. And let's just copy this over to here and call it question 2. And in this case, we're solving for the present value. So this will be PV equals, and over here, this will be PV. But amazingly enough, this information is in exactly the same order. Notice when we do, let's go equals PV bracket, we're still looking for rate, N per, payment, future value, and type. So the only thing we have to change here, let's get rid of this, make this into future value. And we can plug in our values here. The rate, oddly enough, I'm still using 7.2%. The number of periods, I still use 3. There's still no payment, but the future value here is 1,800. So negative 1800. And incredibly enough, we get exactly the same answer. Now we could consider about the cash flow concept here. If the present value is going into the investment, the present value should probably be negative and the future value should be positive. So if we make this positive, notice they give us this as a negative number, which is quite reasonable because the cash flow concept says this should be negative, even though when we calculated it by hand, we did not get a negative value here. So you can do it either way, but you have to get used to the fact that one's going to be negative and one's going to be positive. And I usually like to think of it as money leaving my pocket and money coming into my pocket. Money leaving my pocket is negative. So when it goes into an investment, it has to be negative. And when it comes back to me, it's positive. So in this case, the present value is going into the investment. It should be negative. But either way, the number worked out to be exactly the same. Let's just copy that and go back to our whiteboard. Have a text box here, Control V, and we can visually confirm that yes, we're coming up with exactly the same answer. So let's stop that